Hello there, my name is Jack Salford and my partner is Mark Nathaniel, and today we'll be presenting our research proposal titled The Baryon Cycle and Baryon Characteristics. In this research proposal, we'll be explaining the introduction, research problems, objective, literature review, expected results, and methodology.
And today, we are going to be talking about our research proposal, Baryon Cycles and Planet Characteristics. Now, of course, there are several things we're going to be covering today, those being the background of our research, some literature review, our methodology, the results we expect to see, and a convenient flowchart. Now, what is meant by a baryon cycle? Well, the baryon cycle refers to the flow of gas in and out of galaxies, and this flow is self-regulating. Now, what I mean when I say self-regulating is that each baryon cycle influences the next. And to talk about that, I'm going to have to get into exactly how gas enters and leaves galaxies, right? So the center of each galaxy is a supermassive black hole. Now this black hole pulls in these gases, and these gases are, well, star-forming gases, so they form stars, right? And when stars die, some of them explode into supernovas, blasting gas in all directions, including out of the galaxy. And more gas means more stars, and more stars means more supernovas, which means less gas, and that's what I mean by self-regulating. This is also known as, well, feedback, right? Baryon cycle feedback.
The baryon cycle cannot act consistently and can produce different scenarios. The term that is used to explain the baryon cycle is called a feedback. The baryon cycle is highly dependent on the impact of the supermassive black hole that produces the feedback, called an active galactic nucleus feedback, or in simple terms called an AGN feedback. This is very important to understand the concept of the feedback because this is a very important variable to find the rate of star formation. This feedback comes in two groups, which are AGN feedback positive and negative, and both are very complex to understand. To put it simply, the AGN feedback positive, as shown in the table, can compress the gas to trigger star formation to form a new star. However, the AGN feedback negative, as shown in the table, suppress star formation by preventing gas from cooling or sweeping out gas from the host galaxies. AGN feedback is very important to understand because it has a huge impact on our research proposal. So why are we doing this research proposal? There are a few reasons that this research proposal is conducted. Firstly, the increasing population in the world has taken up so much space on Earth. A survey from the United Nations concludes the increase by nearly 2 billion persons in the next 30 years, from the current 8 billion to the 9.7 billion in 2050. And could peak at nearly 10.4 billion in the mid-2080s. More population increase the space needed for the population to live, and with the increase of population on Earth, more resource is needed for necessities and for the population, and which takes to our next point, the frequent disasters globally. With more populations come with more space, and so do disasters. These are cut to make new homes that can lead to many little disasters such as flood and earthquakes. Malaysia's worst floods in decades occurred in 2021 when there are 54 deaths and the army was mobilized. This proves that over time, Earth is becoming more and more dangerous to live in. My third point is that natural resources are becoming lesser and lesser each year. With the increasing population, as I stated in my other points, the need for resource is becoming higher and higher, and more natural resources such as fresh water, oil, and coals. This indicates that we need to find a way to produce natural resources in a large scale. The best way is to find another planet similar to Earth to extract natural resources for our daily needs. The primary objective is to identify stars which are suitable for supporting human life and the rate of location which such stars will appear. This will help us to identify a suitable planet to live that is near us for generations to come. But if we need to find the rate of suitable planet, we need to understand the baryon cycle. So the First secondary objective we try to achieve is to understand how Baryon cycle may affect the rate of producing a habitable star. Secondly is how to define a habitable star. We know that a habitable star is where planets could support life, but how? This will be explained later in this research proposal.
Thank you, Jakes. Now here we have our literature review talking about roughly the same concepts I've mentioned earlier. These are all pulled from related studies on the star formation of galaxies, right?
In this page, we will explain how do we intend the timeline looks like. As you can see here, the intent to launch a new line of satellites specifically for this research. The satellites that will launch will collect data about the gas flow of galactic atmosphere and send the data to us. The satellites will be sent to nearby area where Baryon cycle and scenarios has been recorded in the galaxy, and the current Baryon cycle scenarios is our galaxy and to be observed, and then the data is sent to us. Then we will collect the data from the satellites and arrange them by age, characteristics, and area. After that, we will construct simulation based on the data collected to create a more easier and less time consuming way to create a result that we wanted. The simulation will run a few tests to make sure that the data in the simulation is enough to predict the Baryon cycle. Then the simulation of data collection begins. We will conduct different scenarios for different results. This is very important because we need to find a way to find an answer from an infinity possibilities. After we had enough data collected from the simulation, we will construct a comprehensive model of the Baryon cycle.
Of course, stars mean nothing to us without planets, since we can't live on stars alone. Earth lies in the habitable zone, also known as the Goldilocks zone of our sun. This means that it's just the right distance from our sun to support human life. If it were any closer, it'd be too hot, any further, too cold. The habitable zone is different for each star, but hotter stars tend to have wider habitable zones. Learning more about the star formation rate and star formation history of our galaxy will allow us to determine where habitable planets in the Milky Way are going to be found, and even model these planets in our galaxy. This is going to become very useful as we slowly expand, become an intergalactic civilization.
That's all from us. Thank you.
Learning more about the star formation rate and star formation history of our galaxy will allow us to determine where habitable planets in the Milky Way are going to be found, and even model these planets in our galaxy. This is going to become very useful as we slowly expand, become an intergalactic civilization.